In this final segment on copy semantics, we'll discuss copy assignments. Now, the copy assignment operator is the operator that's called when we want to copy one existing object into another existing object of the same type. Now, the operator for assignment is the equal sign. So when we want to prototype this function, the name of the function is going to be operator word with the symbol, which is equals. The copy assignment operator returns a reference to the type of object that it just copied. So in this case, class name. And it takes as its input parameter a const reference to the object that it wants to copy. And the reason for this is that we don't want the object being copied changed. So that's the const part, and we also don't want to make a copy of it. We basically just want read-only access to the object that we want to copy, and that's why we pass it by reference. By default, C++ gives us a copy assignment operator, which is shallow copy. It's just an element by element copy. And as we'll see, there are some times that we actually do need a deep copy, and then we have to define the copy assignment operator. So let's see what happens in our complex class. So in our complex class, we don't really need anything more than a shallow copy because the private data are just the real and imaginary part represented as devils. So let's see what happens when we do copy assignment. So inside main, we have C1 and C2, and then we call C1 equals C2. So when we call right here, C1 equals C2, we are just going to call the default assignment operator, and let's see what's happening. So when we create C1, we will have created an object with 2 is the real, 3 is the imaginary, and then C2 with 4 is the real, and 5 is the imaginary. And then when we do this call to the default assignment operator, the real from C2 is going to be copied into the real of C1, and the real and the imaginary of C2 is copied into the imaginary of C1. So that is what the shallow default copy constructor does for us. Now, when we are calling the copy constructor, the right-hand side is whatever object that we are passing in to be copied. So, and the reason why I just want to refresh your memory about this is that when you assign an operator as a member function, the implicit assumption is that the left-hand side, that this is the object for which the operator is being called. So left-hand side is the this object. So another thing I wanted to mention is that we make sure that we return the value by reference so that we can change. So we have to return the object that was just copied over by the right-hand side. So we have to return the left-hand side object. And recall that the left-hand side object, the object for which this function is being called, is this. It uses the self-reference pointer this. So when we return a reference to it, we dereference this, and that's what we return. So let's look at the implementation of the copy assignment operator for the complex class, and then how it's actually used. So once again, the signature is going to be the name operator equals, because that's the assignment operator. Then it returns a reference to a complex object, and it takes as its right-hand side parameter a const reference to a complex object. Now, if we look inside the implementation of the operator, overloaded operator, assignment operator, we can see that all it does is it takes the right-hand side argument, it copies the real of the right-hand side into the left-hand side. So that's the same as putting this object's the left-hand side. So this is the left-hand side object. This real and this imaginary. It just takes the right-hand side, real and imaginary, and copies it into the left-hand side's real and imaginary part. And then it returns this. And just remember, returning star this is dereferencing this pointer, which is the left-hand side. So it returns the left-hand side object by reference. Let's see what this looks like in main, and I just want to put this here too, just for review. This is the self-reference pointer. Okay, now let's see what's happening in main. So in main, we declare two objects, C1 and C2, as we've done before, and then we want to do this assignment, and we also declare two objects with the default constructor, C3 and C4, and then we're going to do this statement right here where we're actually doing two assignments. So I want to break down what is happening in these two assignments. So the first thing that's going to happen, step one, is it's going to do this assignment C3 is equal to C2. And just to be clear, the left-hand side is C3 and the right-hand side is C2. So that's why what's going to be called is the assignment operator with C2 passed by reference. As a result of this, what is going to be returned by reference is C3. So that's the second part. So that is when we have this statement, C4 is equal to C3. What's happening is now the left-hand side is C4 and the right-hand side is the C3 that is the result after the copy. C2 is copied into it. So then we're calling C4 with the assignment operators being called, but now we pass in C3 as the right-hand side by const reference. And as you can see, this is an example of chaining. We have just chained these assignments, and you can see why we return these objects by reference from the assignment operators to facilitate this type of chaining. Okay, so what might be clear is that we didn't really have to write an assignment operator for the complex class. The shallow copy would have been sufficient because we're just copying over the real and the imaginary part. But now, let's consider an example when we actually do have to write. And so it turns out that the assignment operator can be overloaded with different types. And in this example, it wouldn't be called the copy assignment operator. It would just be called the another version of the assignment operator, overloading of the assignment operator. In this case, you can overload the assignment operator rather than taking a complex object as the right-hand side. It can take an integer as the right-hand side. So in this specific example, it would still have the name operator equal, and then it would still return a reference to this, so the complex object by reference. But now you'll notice at the right-hand side, it's taking in a const reference to an integer. And the main difference here is that now the assignment operator in this case just makes the imaginary part of the left-hand side 0 and the real part of the left-hand side the integer. So implicit in this is we're modifying this object. This is the left-hand side object. And we're returning a reference to the left-hand side object. So that's when we return dereference this, we're returning a reference to the left-hand side. So once again, let's see what's happening in main. So we declare our complex object C1 using the constructor, which takes the real and imaginary. And then we declare 3 more complex objects, C2, C3, and C4, which are created using the default constructor for complex. So now let's see what's happening right here when we do this chained assignment. So the first thing that's happening is we're going to C4 equal to 5. So that's going to be step 1. And when we do this, C4 is the left-hand side and 5 is the right-hand side. So we're going to be calling C4 operator equals 5. That's going to be the first call. That's step 1. It is going to return by reference C4. And then we have our call C2 equals C4. And I just want to highlight for a moment the different functions that are being called. So right here, for this, we are calling this function. And now, when we have the left-hand side complex and the right-hand side complex, we're calling the assignment operator, but with a different signature. So here we have step 2. We are going to call C2, since it's the left-hand side object, assignment operator, with the object C4 from the previous step passed to it, and we will return C2 by reference. So then C2 is going to be copied over by C4. But in this case, the operator that's being called is the proper copy constructor. So you'll notice that we had 2 different overloadings of the assignment operator being called, and it also reinforces why we return the left-hand side object by reference for chaining assignment. So this is another example of chained assignment. But I just want to mention that in this example, we have the chaining, but we're actually calling 2 different operator equals functions. So we're overloading the assignment operator and we're calling each of those. Okay, so this is an example where, well, the integer one, we actually, shallow copy would not have given us enough because we wouldn't have known to just make the imaginary 0. But now we want to give another example when a shallow copy is absolutely not sufficient for us. And that example is back to our string class. So as you can imagine, just copying the addresses aren't enough. We have to figure out how we can actually copy the memory also. And copy assignment operators are slightly more tricky because we have to be concerned about self-assignment. And self-assignment is something of the form S1 equals S1. Now, how we've written it now solves this, but I want to show you after we talk about how to do it correctly, what goes wrong if you didn't do it correctly. So first I want to trace out what's going to be happening when we do a copy assignment, and then I will discuss the code for how we actually implement it. So this is what we want to happen. I'm going to draw in main what we want, and then we'll talk about the code in a moment. So here's our stack, and here's our heap. So the first thing, we declare S1, and both of these, S1 and S2, are declared. When they're declared and instantiated, it calls the constructor that just takes the string. So here, so for S1, we create the length is equal to 5 and the buffer. And when we create it, we create the buffer on the heap, which is initialized to hello. Okay, so that's when we create S1. And now we're going to create S2. And when we create this string S2, we once again have to create our buffer and the length, which happens also to be 5. And when we do this, we have to create an array of strings on the heap that can contain the word world. Okay, and then we have our S2 pointer, unique pointer pointing to our string world, our array of characters world on the heap. So now what do we want when we say that S2 equals S1 is we want the buffer that S2 is pointing to, its own copy, to say hello. So how do we do this? We want to put in green what is good to do now. So what we're going to do is we're going to allocate another buffer. We allocate the buffer large enough to hold the string hello, so it's going to, and the null character. So we're going to allocate this buffer. So once we allocate a buffer with enough space, we're going to move S2 to point to this new buffer on the heap. And then we are going to do the copy. So here the copy is just going to copy hello into the new buffer. And when we do this, S2 will no longer be keeping track of its old buffer. That will be deleted for us by the unique pointer when we reassign it to the new buffer, and we can update this address to be 5. It just happens to be that they're the same. In this case, they're both strings of length 5. So now let's trace through what this looks like in the code, and I will change colors again so we can talk through the code now. So you'll notice that here we have our assignment operator. The name of the function is operator equals. It returns a string by reference, and it takes the right-hand side, the string that is being copied into the right-hand side string copied into the left by const reference. So it is not changed, and you can think of this as like a read-only access to the right-hand side string. Now let's look at the code. The first thing that we do is we check for self-assignment. And where do we precisely check for self-assignment? Well, when we compare the right-hand side's address, so ampersand right-hand side gets the address of the right-hand side operator, right-hand side object, and compare it to the address of the left-hand side. If it's the same, we don't have any work to do. This is the same as this case right here, and we can just return a reference to the left-hand side object. So that's this. So we can check for self-assignment, and if it is the same object, we don't have to do anything, we can just return. Otherwise, we have to step through what we had just traced through. So now in line 2, this is where we make sure that we create a buffer large enough. So here we have to take the size of the right-hand side, the number of characters on the right-hand side, plus 1 for the null character. So we have to allocate a buffer of sufficient size on the heap. So this is 2, creating this character array on the heap. And then it has to make sure that we return a unique pointer, which is keeping track of the memory that we just allocated on the heap. So that's what step 2 is. It's allocating the memory on the heap when we call make unique, an array of characters of size, right-hand size plus 1, and it's updating the string choose buffer to point to it. Then we can update the address, the length of the string here. We update the length of the string, and then we actually do the copy using string copy. So we just copy everything that's in the right-hand side's buffer to the left-hand side's buffer. So we're copying everything in the right-hand side's buffer to the left-hand side buffer. And then once again here, we have to return the pointer, the reference to the left-hand side. And we do this by dereferencing this pointer. Something that can go wrong. So for example, if you skipped step 1, this is what can go wrong. And I just want to draw what happens. So if you skip step 1, things will go badly, but they won't go as badly as segmentation faults because we are using the unique pointer. So what's going to happen? If you skip step 1, so if I had something like S1 equals S1, and I skip this step right here, what happens is I will allocate a buffer on the heap large enough to store hello. And I will update my pointer to point to it. Okay, so far so good. This memory is now gone, which is not what we want. So then I can update the size and that'll be fine. So step 3 will be fine. Now the problem is going to be step 4, because what's going to happen, when I do string copy, it's going to be trying to get the same address. Let me just make this more clear. It's going to view string copy this buffer get, which is right here. And it's going to do right-hand side buffer get. Those are the addresses that's going to be returned, which is also right here. But since the right-hand side is equal to the left-hand side, you're just going to be trying to copy from the same source and destination, and they both happen to be empty because you just allocated this on the heap. So our string hello, so the result of this is the original string contents is lost. That's what we don't want you to do. So if you skip the self-assignment check, you'll lose the contents of the original string. Now, in the past, if you did this incorrectly and you were managing the memory, the raw pointers yourself, you could actually segmentation fault here. But here, you will just get an empty string. You will destroy the contents of S1. So in some respects, that's better. But I just want to point out that's what happens if you forget to do the check for self-assignment. So I just want to point out this is the very important check for self-assignment. Okay, another way, if you don't want to bother checking for self-assignment, is if you always create a temporary buffer, copy the contents of the right-hand side into the temporary buffer, and then do the copy into the left-hand side. That always works. So let me just point out another strategy that always works. So another strategy that always works is 1, create a temporary buffer, which is the temporary array of characters on the heap. And then what you do is you copy the right-hand side buffer into the temporary buffer. And then once you do that copy, all you need to do is copy the temporary into the left-hand side buffer and you're good. Into the appropriately sized okay, and once you do that, you're good. So this is another strategy that is also safe to use. You just create a temporary buffer, copy the right-hand side buffer into the temporary, allocate a large enough buffer for the left-hand side. So the new left-hand side buffer is going to be the same size as temp and right-hand side buffer. Copy the temporary into the left-hand side buffer, and then you're good into that. And by copy, I mean you can just move the pointer, if you move the unique pointer to do that. Okay, so that's a strategy that you can use in order to avoid losing the contents of the original string if you have self-assignment. Okay, now just want to offer some tips. So the copy assignment operator takes a const reference to an object of the same type that already exists. And this is so essentially so we don't change the right-hand side object and we have read-only, basically read-only access to the object directly. We should definitely check when we're writing a copy assignment operator for self-assignment or any initialize. members. And when we're writing assignment operators, we should return an object of the same type by reference, and often we return the left-hand side by reference. So this is the left-hand side. This is the self-reference pointer. It is the pointer or the address of the object that for which the operator is being called. So you return a reference to it by dereferencing the this pointer. And so another thing that I wanted to highlight that may not have been clear but may be more clear now is that when we have the copy constructor, not the copy assignment operator, the copy constructor, the reason why we pass in the input parameter by const reference also is because we want to make sure we get read-only access to the object from which we're making the new object. And that read-only access is very important because we don't want to make a copy because the copy constructor is called for that. So that's why we pass const reference so we don't make a copy, and the const make sure we don't change the object that we're using to create a new object. So how do you know when you need a shallow or a deep copy? So you need a shallow copy if you only need to copy data members. You need a deep copy if there's some memory on the heap that you want not only what it's pointing at, but you actually want the contents. So an example of when the shallow copy was sufficient was the complex numbers class. A deep copy was necessary for the string object class because we had this array of characters on the heap. If you have to write your own copy constructor and assignment operator, that indicates that you need to make those deep copies of the memory on the heap. And this is usually the case when you have dynamically allocated memory, that you need to make this deep copy of the memory when you make copies. And if a shallow copy is good enough, you do not have to bother with writing a copy constructor or a copy assignment operator. However, I do want to mention that we want to encourage you to adopt some practices, and the main practices that we want to suggest to you for managing copy semantics is, if a shallow copy is good enough, as with the complex class, just let the default copy constructor and default assignment operator be sufficient for you. Don't have to write anything. If you do have to write a copy constructor, then that means you have to use the rule of 3. So if you have dynamically allocated memory, that means a deep copy is needed. Then you need to implement the copy constructor, the copy assignment operator, and the destructor. And oftentimes you also have to implement the constructor also. And so a more recent rule is the rule of 5, whereas you also have to implement move constructor, so move semantics. And we're not going to get to that, but that if you've ever seen the rule of 5, that's what that's referring to. But we're going to advocate in this class, especially when we get to STL, is the standard template library container classes, is that whenever possible, don't write your classes where you have to define default constructor, destructor, or copy constructor, or copy assignment operator. Let the language do the work for you. So you want to just define your classes so that you do not have to do any of these copy semantics yourself. You can use existing classes that will do them for you and very efficiently. Thank you.